Hi everyone, this is CFRG. We don't have too many people in the room. We really hope that someone will join us, but we have to start. So this is CFRG. Together with Alexei and Nick, who is attending remotely, will chair this session. And if you are here for CFRG, please stay. If you wanted something else, please find your room. So we are ready to start. And first of all, the trivia. The session is being recorded. We have a minute taker. Thanks a lot to Dan York, who will take notes. And we have a Jabber comment relay. And if you forgot to scan the QR code and register at the meeting, please do so. We have the notepad, and for all new participants, if you haven't read it yet, please do this. And all sessions, including this session, is being recorded and live streamed. We would like to underline that there is a code of conduct in IETF and IRTF, and you can read about this in these two RFCs to know more. We've got two sessions. The first one has just started, and as we can see, most of the participants are attending online. And we have the second session that will take place on Thursday. It will be a 2-hour session, and I hope that we'll be able to discuss everything we have planned. The agenda and the slides have been uploaded to the data tracker. Please find them using these links. We'd like to remind that the CFRG is not an IETF working group, but it is an IRTF research group, and that means that we conduct research, and it is not some kind of standards development organization. We provide guidance, we provide recommendations for everyone who seek for them. And we'll talk a little more about this during our second presentation related to post-quantum camps. We'll start with research group document status. We had many new RFCs in the autumn, so we don't have new RFCs since November, but we have 3 documents in the RFC editor's queue or in IRSG review, including the CPACE draft, which is the winner of our pack selection contest. Together with RSA guidance, it's in IRSG review, and AGIS is in RFC editor's queue. We've got 2 documents in research group last call. It's AED limits draft and DNHP key. And we need some opinions for both of them, especially for AED limits, because we really want to finish that last call, and we don't want to extend the last call once more. So please, if you think that you can add something valuable to discussion, or if you just are able to read the document, please do so and express your opinion on the list. We had the last call for the previous version of this document. Some changes were made, and then we started another part of the same last call, to be honest. And we want to have some conclusion, so please support the document if you want to support it, or please send your comments or concerns if you want something to be changed. AAD limits is a very important document for us because we want to deal with all generic questions about AADs before thinking about adoption of some new AAD documents. And we have some requests, so it's important for the group to move on. We have 13 active drafts. All of them are important, all of them are really active, and since it's an enormous number of active documents, we don't really want to add some new work before we deal with something in our current deck, but of course we are open for all discussions. If you want to participate in the process with any of the documents, please contact the authors or the chairs because the help is always needed, especially for all post-quantum or combiners documents, because we have a design team, we will have a lot of people working on them, and we always need your help or your opinions. Some of the documents are active now, but they were expired for a lot of time, especially the parent-friendly curves document, which was on pause for a long time, and now it's in active discussions again. Richard, do you want to?
Just
please.
thanks. You mentioned the offer of, or the need for help with some of the hybrid chem documents, especially. We published new versions just before this IETF, which I believe have nice, fresh new proofs cited in them. So more review would be very appreciated on those. Folks can take a look at some of the e-prints that we're linking to that lay out the new proofs of the various security properties for the constructions we have. That would help us get these done and get them out to where people can use them. Thanks.
Thanks a lot, Richard. And yes, please, if you want to review any of the documents, including this one, please do so. We always need your opinions. We have some documents about some general questions like guidelines for writing cryptography specifications, and we want some new process with some general stuff to be started regarding the post-quantum chems, and we talk about it a little later. Another important topic is our crypto review panel. It is a very significant and important part of CFRG. This is a panel of experts working from September 2016, and we had 3 rotations of the panel, and we are ready to make another rotation in April. This is a panel of experts who help the chairs to understand the current status of the documents regarding the security assessment. We always ask them to provide their reviews before starting the research group last call, and we don't do last calls before getting some reviews from the panel. And ISC and some IETF working groups can always ask for the help from the panel to review their documents when it is needed. And we thank the current panel, current 9 members of the panel, and if someone wants to join, we will be happy for your self-nominating or nominating someone else. We'll send a message to the group with call for nominations in April. So if you want to join, please be ready for that. And I think that's all for chair slides. Any questions? Comments? Okay, then we can start with the second presentation. Nick Sullivan will tell us about our vision for PQ camps and our path forward to them. We had a lot of discussions and we think that we know how we can move on. Please, Nick.
Okay, can you hear me in the room?
Yes.
Okay, it's a little echoey. So we've talked about this a lot. There's been very active discussions on the mailing list about PQ chems beyond ML Chem and including ML Chem. There's been discussion from different groups, different protocols that have different requirements. We had a survey at IETF 123, a poll in the room, to ask the group what we should do with regard to specifying different PQ chems. There have been presentations about NTRU, Classic Macalise, Protochem, NTRU Prime. People have mentioned HQC. The IETF needs guidance as to if they want to make a choice between these. And so rather than specifying them in the CFRG, the audience poll suggested that we first produce a chem security requirements document. We're moving forward with that suggestion from the group right now. So here's the proposed approach. Currently, there's no requirements documents. Every IETF group incorporating ML Chem or anything else needs to write their own security requirements documents. Luckily, we have one individual draft by Scoffler and others that covers a wide array of security considerations you might have for ML Chem. But we don't have it for any other chems that people are interested in. So the path forward that we're proposing here is to adopt a group of documents under the topic of PQ Chem security considerations. And if anybody who's a proponent of NTRU, Classic Macalise, any of these, want to put forward a security requirements document that is as comprehensive or more than Scott's, then we will consider that. And we're going to give the group 6 weeks to come together. We are not going to be accepting PQ chems that have not gone through extensive public cryptanalysis via an open process in this. So just keep that in mind. If you have your own magic PQ chem that no one's ever seen, except for you, we're probably not going to include it in this process. So here are the sort of questions for the group. Security considerations are vague. There's not really across the IETF a very strict list of things that we want to cover here. I think we should be more comprehensive within the CFRG. But what that criteria is needs to be discussed and can be discussed. And so the questions here are, and these are for discussion on the list, we can, unless somebody wants to come to the mic, but do we need a design team to come up with a common evaluation criteria for PQ chems? Could go either way. Is a mailing list discussion where someone lists what is the bare minimum to be covered in a security considerations document for a PQ chem. Again, this depends on how much discussion happens on the list. And the third question is the most important. Is there anybody who's willing to write a security evaluation document for any PQ chem other than ML Chem? And without this, there won't be a security considerations recommendation from the CFRG for any IETF groups for any ML Chem, any PQ Chem other than ML Chem. So if people have other suggestions, people have other preferred chems, this is your time. You have 6 weeks to come forward with a security considerations document. Rowan.
Just I ruined me. Stupid question. What's the proposed output of this process?
Right. The proposed output of this process is an adoption of a group of documents, each of which provides security considerations for IETF protocols for using a already specified PQChem. Eric?
Yeah, so I guess how as a consumer of this output am I supposed to interpret that output? So you do one for HQC, and I'm supposed to interpret that how the HQC is cool, totally fine to use. What am I supposed to read into this?
Yeah, I would recommend taking a look at the ML Chem document for an example of what types of things are relevant, and you can think of anything from which underlying mathematical property does it depend on, to sizes, to side channel considerations, to dependencies on other documents. There's quite a lot, and this is why I wanted to have this as a mailing list discussion. And TLS, for example, is a group in which there's a lot of experts. We have many, many groups within the IETF who don't necessarily have the expertise in-house to do this. So it's not targeted towards the very crypto-heavy groups, but more towards the proliferation of groups who want to incorporate a CAP, who would like them to have security considerations that are well vetted.
Right. So I guess you say TLS is quite crypto heavy, and that's true. But I think it would actually be quite helpful for for CFRG to, I don't know if you want, I mean, recommendations would be too strong a term, although I'd actually prefer that. But I think it'd be good to hear we think especially for the chems that have kind of comparable sort of performance properties, which ones the CFRG has the most confidence in and thinks we should adopt. And it's very hard to see ML Chem not popping out of this, given that we're already doing it across the IETF. But just generally speaking, if you want to do ML Chem and then you want to do another one, I think it'd be helpful to understand from CFRG what the view of CFRG was, without getting too far over your skis, which I understand you don't want to do.
Sure. Yeah. We don't have any considerations other than ML Chem at this point, so there's nothing to compare. But deciding on whether this is simply a set of guidelines versus an actual strong recommendation, that's to be determined and can be discussed during adoption call. Next speaker, Sean Hulu.
Yeah. For the first question, from the technical side, I think a team is more suitable because the evaluation of PQChem is very complex. And for the third question, if needed, I can prepare the documents, but I'm not familiar with the workflow of IETF. So I'm not sure what do I need to do if I write the document. Thank you.
Yep, there's resources to understand the IETF.
Deirdre, I've been helping with the hybrid chem stuff. Maybe mailing list discussion is sufficient. For the hybrid chem stuff, we discussed what we wanted to evaluate for all of these hybrid chem combiners. We talked about things beyond in CCA, like binding properties. We have done a lot of work on those. We're not finding them very relevant to existing protocols in the IETF. Basically, if you get NCCA and you're using anything that uses as a component or by itself one of these new PQ chems that usually use the same-ish recipes to take a public key encryption scheme based on some hardness property, which may vary, into a chem, they have similar-ish properties in general, and where they differ seems not to matter that much. So I don't know if we need to go much further, kind of taking the lessons learned out of the hybrid chem stuff and some of the other, like Scott's document, and maybe just distill that into this criteria, but without its design team. In terms of who will write evaluations for these other PQ chems. We do have a FrodoChem document that's floating in the group.
I
Maybe
think that's more of a specification.
it is, but
than
maybe we
security
can
considerations.
either, cannibalize that document into a security considerations document or ask the editors on that to maybe do that work. So there's that. And then in terms of which ones, and is this a endorsement or recommendation versus just here's us writing up considerations. I think anyone that the research group picks to do any work on will be a little bit of a de facto, we think this is important enough to talk about. So maybe we don't even need to, pick the specific words we're using, because even if we do the kind of lowest bar of, we're just talking about the considerations of this one and this one and this one and this one, but not that one, maybe that's enough of a signal.
Sure. You have somebody in League of Fame.
Hi, this is Gafeli from Bouncy Castle Crypto Library. Yeah, I have a question about MLKEM, that's draft standard. So on the encapsulation and decapsulation key checks, the draft mentions that the library may combine this with the core operations as implementers. Is our safety belt, it just follow the validation step in FIPS 203 to the letter, or is there some implementation wisdom to on how to integrate those checks efficiently without accidentally break the MDCCA security? Thank you.
Okay, we're happy that you read the draft, and Scott can comment quickly, but this is we're not analyzing these drafts at this point. We're discussing process.
Yeah, Scott Fleur, Cisco Systems. When I wrote my original ML Chem draft, I was not considering the question of is ML Chem secure. What I was doing is answering the question, how do you use ML Chem without shooting yourselves in the foot? The obvious question is that what is the general expected target for other drafts? Is it analysis of whether FrodoChem is secure, or is it how do you use it secure? Assuming it's secure, how do you use it securely?
And that's a good question for this. At this point, we're looking for security evaluations for ML for chems, deciding what the final criteria for what these drafts look like is still TBT. We haven't even this is, I imagine this is something the design team or mailing list discussion will cover. Scott, Russ, Scott.
Hi, I find this perplexing. As the chair of the LAMPS working group, we have in our charter that we'll only use NIST approved or CFRG approved algorithms for the PQ work. And this isn't the step to get answering whether the CFRG is approving an algorithm. So I just think it's a waste of time to getting to what the IETF really needs.
Okay, well, CFRG, as far as I know, doesn't approve algorithms. So happy to have that discussion. Valerie?
Valerie Smyslov, Valerie Plus. And I have a question. Are only chems in scope? Do you think about post-quantum signatures, the several evaluation documents?
This is exclusively about chems. Signatures, I imagine if there's enough interest, could go through a similar process and have a similar set of security recommendations. If there's energy from folks who want to write those documents and there's need for IETF groups to have security considerations on signatures. This is the one that has had the most attention and conversation so far, not to say that signatures are not important. And it looks like the queue is locked, and I'll hand it back to you, Stanislav, unless there's something else.
I'm not sure that we have time because we are behind the schedule now, and I propose to move on because we really need to get back to the schedule. We can move it to the list. Thank you, Nick, for this, and of course we can continue the discussion on the list. So our third presentation is about Sigma protocols. And Michaela, Katie, one of you please start. Please take the clicker. It will work in a minute. Yes, it does. Please start.
Hello, everyone. This is about an update on the Sigma protocol in FIA-Shamir IETF CFRG drafts. We're trying to inform and specify how two components very popular in the zero-knowledge literature should be done. One is Sigma protocols that are zero-knowledge interactive proof of knowledge for generally simple relations. And it's so simple that in fact is only 3 messages. And one of them is just a random challenge that's a public coin. And FIA-Shamir, which allows to turn this interactive protocol into a non-interactive one by means of a cryptographic hash function. So together, they allow you to create non-interactive zero-knowledge proofs that can be later used also by other documents. These documents have been now part of the CFRG for a while. Sigma protocols are in particular useful for very simple relations, like for simple, lightweight, anonymous credentials. That's where we found most adoption, but we expect them to be used also in other places. And specifically the FIA-Shamir transformation, we expect it to survive also as we move forward with the post-quantum agenda, because it's such an important component that we expect it to be also useful in the future and also be used in other zero-knowledge proofs that are not Sigma protocols. Since the last IETF, we have been working mostly collaborating with 2 other drafts that have been using these specifications, and this has mostly been a useful, constructive, collaborative effort with other people that I would like to thank explicitly: Armando, Chris Wood, Jonathan, Michael, Sam, and Vishruti. And in addition to that, now, and mostly thanks to this effort, now we have test vectors that are part of the specification. We have Cypher Suite and test vectors integrated, and we are hopefully stabilizing these test vectors so that in the future they can be used as a reference for what should be the input-output of these cryptographic protocols. And kicking off the formal verification for the FIA-Shamir transformation, which is a long effort that will take a while, but we set the basis so that this can be done and can be later used by adopters of this specification. In addition to that, thanks to Lindsay, Victor, and Ian, we built a library that can be used to prototype some of these systems. Given that they've been used a lot for anonymous credentials, we created a library, a Rust library that can be used, for instance, to specify credentials with attributes and how they can be redeemed. And these are like just 2 examples that have been popular in the IETF for rate limiting or for pseudonym authentication. These credentials, there is a wide range of credentials, and there's big discussions, and there will be other discussions happening at the next CFRG meeting. These credentials are particularly easy to specify, and they can also be verified in 1 millisecond or less. So we expect them to be useful now, even though, as it has been discussed for a while, they do not provide post-quantum security from a soundness perspective and only from an anonymity perspective in their basic form. So, like we built this whole stack of implementation, and the 2 things that you see there colored are the ones that have been targeted by the specification effort and that we have test vectors for. And all the things on top, are things that people can build on. And as we, move forward with the standardization of this primitive, the question is also, what about other specifications that are part of the CFRG or that are part of the larger community? There are things like per verifier linkability within BBS, or NIM authentication, or Longfellow, that are all using some of the components here. And so the question for the community is, how do we converge so that we all base everything under one simple specification for the components that are to be reused? So this is it. This is all I wanted to say. Again, wrapping up, these two specifications are about simple zero-knowledge proofs. One is about the interactive protocols that deal with simple linear relation over elliptic curves. And the Fiat-Shamir transformation is how about we make them non-interactive so they can be used in practice. Thanks.
Thanks a lot. Any comments, questions? No? Thank you. And let's move on. Trying to get back to the schedule. Sure. Yes, please, you're happy to start.
Thanks. Hi, everyone. I'm Mallory Nodal. I'm going to make this quick. Also wanted to just start by thanking the chairs for letting me present today. I'm just unable to be here on your Thursday session, which is, I think, when you would have a talk like this. So I'm not going to be talking about any research group document. I wanted to bring in some considerations from research that I have conducted with colleagues at both NYU and Cornell about the use of AI and data-driven features in end-to-end encrypted messaging, video, audio applications, just trying to bring some practice to the theory that you're all worried about. Because I think there's a trend here that we really need to address. So folks might have seen this if you're using WhatsApp now. It's been out for about a year. There's also examples in Samsung phones that are using Google Messages. And lastly, Apple Intelligence got a lot of attention for its announcement last year. Some analysis was out pretty quickly by Matt Green and others, and this paper came out around the same time. So what is it that we're looking at? I mean, in some ways, it's a problem of endness, right, that I think Chelsea Como and Britta Hale had presented on a few years ago. This idea that your phone, which has these apps on it, is potentially working with some of these other features. Feature-rich messaging is really popular, but what happens when you've gone through all this effort to enable strong cryptography for the purposes of confidentiality and privacy, and then you start introducing features that basically just run roughshod all over that, right? So I want you to look at these two screenshots, if you can read them from where you're sitting, because this narrative has not changed. That on the left you have Meta AI in your WhatsApp chats, and it says your personal messages stay private, and it gives you some indication of how that happens, even if you invoke Meta AI in your chats through a variety of different ways, right? For example, summarizing the transcript of a group chat, that somehow that your personal messages stay private. Okay, how is that achieved? We wanted to actually analyze this because these claims are actually very consequential, and we were not actually convinced. So we analyzed the available public documentation for these things and came out with some recommendations for how to actually achieve, maintain, let's say, the security, privacy, confidentiality guarantees of end-to-end encryption if you're using AI features. So this was the main research question. Can you process message content? Can you create derivatives of encrypted message content in a way that's compatible with end-to-end encryption? Maybe there are some narrow ways, but what are they, and what definitely should you not be doing? So we had 4 recommendations about how AI training works and how models trained on end-to-end encryption should or shouldn't claim to have kept that data secure. In situ use, which is what we would consider the processing of that. That's sort of where I'm going to focus my talk because that's the security stuff. The second 2 things are mostly legal. It's in the slides. I'm not going to deal with that today. And if you want the talky talk version of this talk, there's a version of this available online. And you can also, of course, read the paper. But disclosure and consent is basically like, can you actually continue to say these things like your messages are still private? This is still end-to-end encryption. Is that actually appropriate? Click. Yellow. Okay. So let's talk about AI just for a brief moment, and so we can get clear on what we mean when we use these different things. So maybe just to interpret, I think one of the motivations for using AI in messaging applications, one, people like it. You know, maybe it's fun to be able to put like party hats on your friends' pictures. Maybe another reason is that people imagine there's a lot of this already happening in the form of like, I'm on my endpoint on my device, I'm copying and pasting, copying content, pasting it into AI chats and then pasting it back into an encryption app. Maybe you should just make that all in one interface. That could be a form of harm reduction. It could be also just easier. And then, maybe another reason is like messaging conversations are novel sources of content that can then improve models, right? Gives you rare tokens and all of that, but at what price, right? So we talk about the training as really specific in a moment where you might be using some of this content. And then you can also, through the process of inference, this is when you've asked the trained model to do certain things for you, to generate content, to generate images, whatever. And then, the data collection is actually part of the inference, so it feeds back into the training. So how does this happen? I mean, there's a couple ways to do this. If you're going to introduce these features, you could just do it all on the same endpoint, and that would be kind of the equivalent, right? It'd be the automated equivalent of me copying some content, pasting it into my robot, taking the output and putting it back into the chat. You've just like made that easier. But that's not really what's happening because our phones are not really powerful enough to do that. You could do another option where you sort of treat the bot like another endpoint. So you get around having to convince people that my robot is my endpoint, and just give the robot its own endpoint. That would just be like, instead of the ghost proposal, if people remember that, the bots are in the chat. So obviously from user interface, people don't like that, but you maybe notice when you join Zoom meetings that sometimes there's a note taker. That'd be the sort of other option. What's actually happening is on the left, all 3 of the proposals we evaluated are using trusted execution environments in the cloud to do the processing. The data, the content, it's leaving the user's endpoint device, and it's now being processed in the cloud. And there's a really massive push, narrative push, to convince folks that this is equivalent to end-to-end encryption. So we've started small, but obvious. If you train an AI, a shared AI model, meaning other people have access to that model on content that was originally end-to-end encrypted, that is not compatible with end-to-end encryption. And we talk a little bit more in the paper about the specifics of what would the harms be, right? You can recover data in a shared model. We treat it as derivative content, which also shouldn't be considered then any more private content. So that's like our first very strong recommendation. This would not be cool. The second recommendation takes it a little bit further and talks about the processing on TEs. And I just want to say, I'm sure for a lot of you folks in the room, like this is really obvious, but the goals for end-to-end encryption and the goals for trusted hardware may look like they have similar outcomes, may look like they have similar, they feel the same, but they have absolutely different goals. They do totally different things, and they aren't the same. This is one of the core points that we make in the paper. So on end-to-end encryption, you're going for confidentiality of the communication between endpoints. For trusted hardware, you're trying to create confidentiality of the compute. The machine state between the user and the cloud then is the thing that you are creating confidentiality for. Another really obvious one, right, is the mathematical hardness of end-to-end encryption is about security. And then hardware design is the trusted encryption goal that deals with the specification for security there. So one is about mathematical hardness, the other one is about the hardware itself, right? So again, like not the same thing. We actually were able, I think we came up with a framework, you know, as a lot of good academic papers do, for how to evaluate this, not just for this case, but I think in general, this could be expanded to look at a variety of different features for consumer messaging, voice and video apps that are using encryption. But for this, you know, we just can show you in a pretty straightforward way what we think would be cool. So, you know, compatible with end-to-end encryption would be on-device models. Again, probably not achievable for most devices today, but still something that's possible. The other thing that we also point out in the paper is that fully homomorphic encryption, again, without fine-tuning though, would also be compatible. So we give those two things as caveats. Just jumping to the end, right, the most vulnerable thing would be server-side plaintext inference without fine-tuning. Like, definitely don't do that. For what it's worth, I don't think any of the papers we evaluated actually are proposing that, right? But then the things that fall in the middle are kind of what folks are proposing. So, you know, it's not compatible with end-to-end encryption to be doing all this processing off device. We really, really want to impart that on the folks who are deploying this and the folks that are working with deployments to improve them, to guide them, to suggest guardrails around that. So that's sort of, I hope, hopefully the outcome of this paper. This is, you know, if you're interested, the text of the second recommendation. We want to encourage endpoint local processing. If you can't do that, then you should make sure that there isn't a third party that can see the content or that can see derivatives of the content. We're talking about like message summaries or things like that. And that, you know, the end-to-end encrypted content is exclusively there to fulfill the user's requests and nothing else. For example, you know, you're not trying to obliquely figure out, you know, preferences or things that could be used for advertising, things like that. There may be other, you know, equities and incentives involved when we want to go ahead and say that that would be, that would contravene the promises of an end-to-end encryption, if it wasn't already obvious. Like I said, I was going to speed through this, but the paper includes a great deal about the legal questions around consent and disclosure because these are being framed as privacy-preserving or end-to-end encrypted messaging apps, even if we feel that they don't actually deliver that anymore with these AI features. And one thing I just wanted to point out is that, you know, at some point, before all this AI stuff, you know, Zoom got actioned by the FTC because they were calling their product end-to-end encrypted, but it wasn't on by default. And that was like the basis for the FTC telling them that they could not market anymore Zoom as E2E, for folks who remember that. So it's one of the sort of things we highlight in that. Skipping ahead, you know, if you're going to be doing this, you need to give users disclosures. You need to give them opportunities to opt out. And so we do see that, I think, in the apps and things that we've looked at. I will leave it here. I know we don't have a lot of time today, but I did want to say that we just updated this paper last week. So it's fresh. It's got some little bit of conversation in there about a variety of new developments in the space. And so maybe folks will find that useful. Thanks.
Thank you very much, Mallory. Please, John.
First thing, I hope use of advanced crypto in phones doesn't turn out to a privacy theater. We have seen leaked report from FBI before that actually Meta and iMessage, WhatsApp gives the police a lot of information, even like if you store it in our cloud, a lot of the past. Question 15, you said that FHE, fully homomorphic encryption, is compatible. Wouldn't you need some multi-party computation?
Could you repeat, wouldn't you need some?
Slide 15, you
Yes.
said what is compatible, and then you can say that the server could do AI training on using fully homomorphic encryption. Wouldn't that require some multi-party computation? My understanding is that fully homomorphic encryption, you need the private key to actually extract any data.
Yeah, so just to be clear, it wouldn't be for training, it would be for processing. And I think what we were trying to say is that, there are some conditions in which you could create derivatives of encrypted content, like summaries or I don't know, the ability to do keyword search. Like there's a bunch of stuff there that if you were to use fully homomorphic encryption, that would still preserve the encryptedness, right? You would never have to decrypt. You would never be using the plain text in order to get that output. And so therefore it preserves end-to-end encryption. But it's the same problem. It's very expensive on device. It's unlikely to be implemented at scale. So
can you get any output from fully homomorphic encryption?
That I honestly just don't know. I think that's, this is, I know Deirdre has talked about this in the past too. So for folks in that room, or Deirdre, come on and talk about the specifics of it. I just, we wanted to mention that as something that, it doesn't get decrypted. It's not plain text. We feel like that would be compatible.
Okay, thanks. And I'm saying that we don't have any time for new comments. Maybe you should also ask for some guidance in SEG, because CFRG can think about challenges here, but we don't have any guidance for you just now. So maybe you should go to SEG, and maybe they will have something more. Thanks again. And our last presentation, Nick Sullivan, please start.
Okay, can folks hear me? I'm hearing some echoes, but I was told that I was quiet before. Yes, no? I'm assuming everything's good. Okay, so this is, my hat is off for this, my chair hat is off. This is an individual draft that I put together because of a series of confusions that we've had across the IETF, which is something we have not had to do for a very long time, which is bringing new primitives into the IETF more broadly. So I put together a document. It's structured as a BCP, and it hopes to answer the question, how do we standardize cryptography at the IETF? What pathways exist within the existing relationships between groups, and what has worked in the past and what hasn't, and what lessons we can learn from this going forward. And from sort of a very high level, there is the security fundamental cryptographic analysis, which oftentimes is done at the CFRG or even NIST or other external places. And then there's the concrete decisions about protocol profiles, things on the wire, IANA tickets, IANA specifications, etc. So hopefully this is not a here's how we should do things document. It's a here's a list of ways that we can run into, we can sort of get ahead of decisions or get ahead of issues that happen pretty frequently and have happened frequently even at this IETF. So in particular, what's broken today, oftentimes working groups without cryptographic specialization in the group have used primitives that don't necessarily have a IETF approval or even a review from experts within the IETF. And we mentioned that the crypto panel is going to be renewed right now. As a reminder, the crypto panel is a general resource for the entire IETF. Any working group chair or area director who would like a comprehensive cryptographic review of maybe not an entire protocol, but at the very least, the security considerations of a protocol can come to the CFRG chairs, and we can try to delegate this sort of thing. So sometimes you end up in situations where different groups implement and standardize things that are just slightly different from each other, and that is a very bad situation for us to go in going forward, because it has negative impacts on library developers. Problem two, this is something that's very salient, which is that you know, crypto issues surface at last call that can you know, take a what is a generally uncontroversial draft and cause it to be torpedoed or to be discussed all sorts of different ways and new things brought up. So when protocol documents do reach this last call, well, IETF last call, IESG review, or even working group last call, there could be gaps in the crypto that people step in there, and then it's very, very much too late to go back and start a, you know, CFRG document, which, as we know, takes years to do in order to relieve that. Even crypto panel reviews are scoped in the weeks, right, not in the days. So sometimes fixing design issues like this creates some compromises under time pressure, and documents that are valid or documents that are helpful may get stuck one way or the other. So you know, the review done at one last call in one working group does not have the memory of the reviews done at working group last calls in other groups. And so this is the meat of where this came from and the sort of inspiration for this draft. So if you want a flowcharts are great if you're doing process analysis. But effectively what this document proposes is a two-lane model. One that analyzes, this text is small, I apologize, the slides are available. But there's the cryptographic foundation side, which is the mechanism specification or security considerations. This does not include wire formats, does not include code points, no IANA registries, but it does include test vectors. And then you have this, and these are oftentimes informational documents published by CFRG or external documents published by groups like NIST, for example. And then you have the standards layer, right, which is the protocol profiles. This is wire formats, code points, IANA registries, normative references, sort of common shared vocabulary across working groups. And so this pathway is has a number of decisions here. The first one is, so I can walk through some times that we've done this, but the first one is, it starts with one working group or an individual needs a cryptographic primitive for their protocol. The first question to ask is there a CFRG primitive available? Or is there a primitive available for which the crypto panel has done a review for? And this is not to say that every crypto decision within the IETF has to go through CFRG. We are definitely not recommending that. What we're saying is that in deciding whether to introduce new cryptographic primitives into protocols, it's worth seeing what the rest of the IETF has done, and in particular, the sort of central analysis point for cryptography of the IETF, which is the role the CFRG has played, whether they've looked at it, right? And if they've specified a primitive or not. So the way this worked for Privacy Pass is pretty straightforward. So Privacy Pass wanted a primitive. They introduced this new capability based on blinded RSA or VOPRF. This did not exist. So step number 2, do other working groups need it? And at the end, the answer was no. And I think it's probably still no for blinded RSA and VOPRF. And so this leads you down the path to the final one right here, which is a working group or individual drives parallel work with the CFRG. And this is what we did with Privacy Pass, and it was extremely smooth. well, maybe not extremely smooth, but it worked out in the end. The protocols were developed in the IETF layer, all the code points, all the exact on the wire recommendations, IANA code points were all developed in the privacy pass group, while hash to curve, VOPRF, blinded RSA, because they were not externally specified by an open international process, CFRG went ahead and specified them. So that's what you'd call sort of a happy path that we've done before. And that's sort of if you apply this protocol, this framework from scratch, that's one path that you can get. There are times in which different working groups need existing primitives, and they're not necessarily in the best shape to share beyond an informational document. So HPKE is an example here. This is an ongoing process that's happening. So it goes, the working group needs a cryptographic primitive, and let's just take the TLS group for ECH here. HPKE was originally developed for MLS or in conjunction with MLS, but is there a CFRG primitive? No, yes. Is that on the standards track? No, it was an informational document. And the question was raised, should we promote this to a standards track document so that it can be referenced without downrefs by everybody and not sort of suited from just a research document. And this led to a dedicated working group that republished the profiles. So this is another happy path that we are trying and is currently working through. The idea is that these dedicated working groups are tightly scoped and focused on delivering outcomes to enable a wide variety of working groups to use a primitive in a way it's been analyzed and looked at from an IETF usage perspective. Okay, that's HPKE. It was mentioned earlier in this conversation about PQ signatures. So there's currently debates in different groups, massive debates. I was just in Jose, or previous to this, about PQ signatures, which ones to use and how. If you were to follow the process here, 2 years ago when originally the combiners or signatures were being explored for lamps, it could have followed this path where the working group needs a cryptographic primitive. CFRG doesn't have anything on PQ signatures. Do other working groups need it? Yes. And the conclusion here is potentially form a dedicated working group targeted within the IETF on PQ signatures within the IETF. And this would work in partnership with CFRG, which could provide reviews on the security considerations or even a full security considerations document on the PQ signatures that would come forward through that. So this is kind of the overall view of what this process could look like for introducing and standardizing new primitives and not having bike shedding happen in 17 different working groups all around the world. I would focus it all in one place. If it's small enough, focus it in one working group. If it's very, very small, focus it on the one person who's developing that draft and work in consultation with the CFRG to ensure that no security issues happen. So we don't have a lot of time here, but I want to leave this up for discussion. This is an individual draft. From my perspective, I've been sharing it around, getting folks' opinion on this, and as to whether or not this could be a helpful way to view the IETF processes that are available to folks to end up with a positive outcome going forward. So there's some discussion questions here, but I'd rather go and take questions from the audience, if we have any.
I would like to add that we will start the Thursday session with 10 minutes allocated specifically for this discussion. So we'll update the agenda, and on Thursday, first 10 minutes of our session will be dedicated to this discussion. So if anyone wants to say something, please do it in the beginning of our session on Thursday.
Probably better because very few people have read this if we were to do a poll.
And now we are out of time. So thanks everyone for attending. We are waiting for you on Thursday and have a nice lunch.